Hi, my name is Aryasree, and I will be showing the simulation part of this our project. So this is the board that is being used here. Uh, I will show you once again. I'm sorry, I'm mute for the at the beginning. So I will once again show you this. So these are the displays that is being used here. So this is our board. We are using Arduino Uno board, and this is the PiximLab simulation of this board. There are 14 pins, and there are 14 digital pins and also 6 analog pins, and the naming of the pins is given in the board. This is the Atmega 32 is the processor or controller that is being used in this Arduino Uno board. This is the transmitting and the receiving LEDs. Once a bit is transmitted or received, this LEDs will be used. This LEDs will blink when the bit is being transmitted or when the bit is being received. This is the inbuilt LED light inside this Arduino board, and this is the reset button. And here we are having a two ports for the cables. So that is all about the board. Since I am already using this board, it is in the on position. And as I already said, these are the digital 14 digital pins. This one, two is the transmitting and receiving pins. And here we have also ground pin, voltage pin, V-in pin, etc. reset and input output reference pin. Uh, these are the pins that is being used here. Analog pin. This analog pin is based on pulse width modulation. Now, going back to the things. So here we are having the display for our project. What all spare parts that is being used are presented here. This is the LCD, CLCD, and this pin connections and all are given. Uh, Here we are connecting SCL to A5 and SDA to A4. And in this pin, we are here, it is the temperature reading. Here, it is the water level reading inside the tank. And here, since I am the blink, I have connected to the blink gap. I have clearly turned off the outlet valve and the cooler. uh, and this is the LDR sensor, and this is the LED. This LDR sensor is that is light dependent resistance as a variable resistance, and what it uses is the light will fall on this LDR sensor, and as such the resistor inside this LDR, the resistor of the LDR will vary. And this is the LED that is being used. We are not using the inbuilt LED. Instead, we are taking externally connecting the LED to the pin 3. And this is the module which is having heater, cooler, and temperature. And this is the Ethernet module. Since Arduino does not have Wi-Fi, it cannot directly connect to Wi-Fi. So it is what we are doing is we are connecting it to the Ethernet module, and through Ethernet module we are coupling it to the Blink IoT app. Now, and this is the serial remote tank. It is based on the level of water in this tank. The reading is being taken here, over here. And also we have an inlet valve. Let me show you the whole thing. So this is the inlet valve and this is the outlet valve. Through the inlet valve, water will be pouring in, and through the outlet valve, the water will be going out. And so that is the this is the serial remote tank. Now let me show you the dynamic uh, 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 simulation. So now I just explained what all are there, what all tools that we are using. Now I am not able to uh, mirror my mobile screen due to some issues in the screen. in my mobile display. Therefore, I will be trying to uh, show you the dynamic flow of the simulation. So I have already connected with the blink, and it is in online mode inside. And here in this, I'm turning on the heater. As you can see, this heater is on. Now, once it reaches 35 degree, the heater will automatically become off. I'm not touching anything. The in my phone, the heater automatically became off. Now I am turning on the cooler. As you can see here, the fan is on. As also here we can see this cooler. Sorry for the spelling mistake. Cooler is on, and you can see the temperature is going to an optimum temperature. Now it is 27.34 in my blink app also. In the temperature gauge, it is showing as 27.34. Now I am turning off the cooler. Now turning on the heater. Temperature is going up. Okay, I'm turning off the cooler and turning on the turning off the heater and turning on the cooler. Temperature is going down. Okay, so I think this is the optimum temperature till which the cooler is this is the room temperature. And now so that is all about this temperature system. Coming back to the garden system, since this is the here there is when the resistance increases, when there is no light, the LDR resistance will increase, and when there is light, the LDR resistance will decrease. So here the LDR resistance is very high. I am going to decrease it. You can see the LED will be as becoming dimmer and dimmer. And once that means here it means there is maximum light, and therefore the LDR resistance value is very low, and also the voltage is high, and which in turn reduces the uh, LED brightness. When there's no light, LED brightness will become more. So that is about the LED. And heater and cooler, as I've already said. Now as I've already said, once the display and all, I can clearly couple it with the blink app. Now I'm going to test the water level serial tank. So this is the serial tank. uh, I have this Arduino is connected to the serial tank through serial communication. My Arduino is connected to COM1 port, and my serial tank is connected to COM2 port. This is the inlet wall. This is the outlet wall. Now, what I'm the water level is now at 2280, which is reflected on my Blink app also, which is at 2280. Now, let me on the inlet value inlet valve by pressing the button in the blink app. So as you can see, the inlet valve is on. Now turning off the inlet valve. Now turning on the outlet valve. As you can see, the outlet valve is on. This green color shows you that the outlet valve is on, and the water is being precipitated. And as you can see, once the water level is at some point, the inlet, what it happens is inlet valve, the inlet valve will on automatically. I have not touched any switches or anything. Okay, so I'm going to uh, terminate the outlet valve, and the water level will increase. Now I am opening both inlet and outlet valve. Okay, this is all about the inlet terminal. As you can see, the volume here and here also it is correctly reflected in both in here and also in the Blink IoT app. I am just opening the inlet valve. I am offing the inlet valve and opening the outlet valve. As you can see, the volume is decreasing. Here also it is reflected. And once it reaches a point, what happens is the inlet valve will uh, open, because the water level should not be below that level. Okay, so and also as you can see, whenever I am pushing the buttons, here it is being reflected over here. Outlet flow off, inlet flow off, inlet flow on, outlet flow, outlet flow on. Okay, so that is all about the simulation part of my project. um, I hope I am very satisfied with this internship and the teaching. I am very grateful to our teacher and the whole team behind this. I am very glad to have found you people. Thank you so much for this internship opportunity. And I am also very grateful to all of the participants who are also in this internship. So I do have some company. I was also able to make some new some connections through this. I was able to meet many people. I am so happy for that. So that is all about the simulation part. Thank you so much.